In this video we're looking at the product of powers property, and what that does is it helps us simplify these problems with exponents. So product means multiply and power is an exponent. So in other words, what do we do when we are multiplying like bases with exponents? So that's what we're working through. And what we do is we end up adding the exponents. When we have like bases, so let's say we have a base b raised to the second power times base raised, that same base raised to the third power, that would be b to the fifth power. So this is the base, just to review, and this right here is the exponent. Okay, so that's the vocabulary that we're using here. So we end up adding these exponents. 2 plus 3 is 5, so final answer b to the fifth power. So that's the shortcut rule. And we always need to multiply numbers times numbers, x's times x's, a's times a's, b's times b's, y's times y's. We can't combine them in any other way than that. So in this first example here, we have an implied -1 right there times a -2. So that's the numbers multiplying the numbers. -1 times -2 is +2. And then we have an x squared times an x to the first. So we have an exponent of 2 here and an implied exponent of 1 there. We add those. 2 plus 1 is 3, so x cubed. So altogether that would be 2x cubed on that one. Let's look at another example. Here's another example. We have -2a squared times -2a squared. So it's always numbers times numbers. So -2 times -2 gives us +4. And then it's a's times a's. So we have an a squared times an a squared. We're multiplying like bases here. The base is a, and the exponent here is 2, the exponent here is 2. So multiply like bases, you add their exponents. So 2 plus 2 is 4, so it would be a to the fourth. So altogether 4a to the fourth. The 4 here comes from this -2 times this -2. The a to the fourth right here comes from this a squared times this a squared. We add those exponents, a to the fourth. All right, let's look at altogether 4a to the fourth. Let's look at another example. Here's another example. We don't need to let this scare us. There are a lot going on here, but if you just stick to the rule, multiply numbers times numbers and variables times variables, you'll be fine. So -2 times -3, +6. That's this -2 times this -3. We're multiplying numbers by numbers there. And then x's, the only x factor that we have here is an x to the fourth, so we'll just write that out. That handles that. And then for y's, we have a y to the fourth times a y cubed. We add those exponents because we're multiplying their bases, so that would be y to the seventh. So all together 6x to the fourth, y to the seventh on that one. Let's look at another example. Alright, in this example we're going to end with a negative exponent, so we're going to have to fix that in the end. So will be a good time to talk about that. So let's start numbers times numbers. 2 times -3, that's -6. And then the v's times the v's, so that would be v to the -3 power times v squared. We add their exponents then. -3 plus 2 is -1. So it's v to the -1 power. We don't ever want to end with a negative exponent. So the way we fix negative exponents, if they're on top like this is on top, you could say that it's over 1 like this. We can always put anything over 1 and it doesn't change its value. That's okay to do. So if we have a negative exponent and it's on top like this, we take it to the bottom and make the exponent positive. So this would be equal to -6 over v to the first power. We do not have to write the first power because it's implied to be there, so we'll just take that out. So that would be -6 over v for that one. Just to cover negative exponents quickly here off to the side. So for example, if we had x to the -5 like this, we would change that to 1 over x to the +5. We just move it to the bottom. If we had a negative exponent already in the denominator like this one, we bring it to the top, so it would be x to the fifth over 1. Of course we don't have to write this over 1, so we can just take that out, and that's why it would end with just x to the fifth. So that's how we handle negative exponents. Let's look at some more examples. Alright, this one is getting a little more complicated, and with our exponent rules there's usually more than one path to get to the final answer. What I like to do is when there are so many things being multiplied together, like in this example, I like to group them together, so numbers with numbers, x's with x's, y's with y's, etc. So that's what we're going to do. I'm actually going to just rewrite this that way. So the only number I have in the problem is this 3 right here. There aren't any others, so I'm going to write that first. And then I'll just go in alphabetical order. So I have an x squared. That's this x squared. So I'm going to start marking them out as I write them. There's an x to the negative 1 right there, so I'll mark that one out. I've got that one down. Y's next, so I have a y to the negative 1 right here. Mark that out because I've written it again. And then y to the 4th. Mark that one out. And then I have a z squared right here, and then a z right there. So we'll write z to the first power there. Alright, so I just marked those out so I could make sure that I wrote them all again. So now I can start applying my rules. So multiplying like bases, I add the exponents. So the only number I have is a 3, so it goes in front. My x's right here, I add their exponents. So 2 plus negative 1 is just 1, so it's x to the first power, or just x. I don't have to write the 1 there. So that handles that. For y's, I have the exponents. I need to add them. I'm multiplying the bases. I'm multiplying those bases there. So I add these exponents. Negative 1 plus 4 is 3, so it would be y cubed. And then here, for the z's, I have an exponent of 2 and an exponent of 1. Add those, that's 3, so z cubed. So altogether, 3xy cubed, z cubed for that one. Again, when they're all mixed up like it was originally, oftentimes it's easier to write them side by side, and that makes them a little easier to work with. Alright, let's look at another example. Alright, another example with a lot going on, so a little more complicated. So what we'll do is, just like we did last time, we'll write numbers beside numbers, p's by p's, q's by q's, etc., and make it easier. So we have a 4 times a 4, so that 4 and that 4 I've written again. We'll go in alphabetical order again, so we'll write the p's next. So we have a p cubed here. We have a p to the first power. I'm going to go ahead and write that exponent for us there. And then a q next, so q to the second power there, and q to the negative 4 power here. And then r next, so we have an r squared there, and lastly an r squared there. So we just rewrote it, same thing, it's equivalent, we just rewrote it so that everything's side by side so it's easier to work with. So now multiply numbers times numbers, p's times p's, q's times q's, r's times r's. So 4 times 4 is 16. P cubed times p, add the exponents. When they're side by side like this, see, it's a lot easier. So p to the 4th power there. And then here, for the q's, 2 plus a negative 4, that's like 2 minus 4, so that's negative 2, so we get q to the negative 2 power. We'll apply our negative exponent rule later. And then r's, we have r squared times r squared, add those exponents, so that's 4r to the 4th. Last step here, we have a negative exponent. We can't end that way, so we take this q to the negative 2 and move it down to the denominator. So we have 16 p to the 4th, r to the 4th on top, and then we're going to take this down to the denominator here. So q squared on top, or pardon me, on bottom. So again, if you have a negative exponent and it's already on top like this one, you move it down to the denominator. If it were in the denominator already, we would move it up to the numerator and make the exponent positive. You want to end with only positive exponents. So that would be the answer for that problem. Let's look at one last example here. Alright, this last example has something that so far we haven't worked with, and that is these exponents of 0. Anything to the 0 power, this is just a rule we need to know, anything to the 0 power except 0 is 1. So anything other than 0 that is raised to the 0 power is just a 1. So working with these, we can actually mark them out because they just become 1, and 1 times anything is whatever that thing is. So we're just replacing them basically with multiplying by 1, so we can just mark them out. So now let's write what we have left. We have a y to the negative 4 times, so that one's taken care of. We have a y cubed, that one's taken care of, and we have a z. So put these together. those exponents together. Negative 4 plus 3 is y to the negative 1 power. And then we have the z to the first power. We don't have to write that first power there. So we have a negative exponent. We can't have that in our final answer, so we need to make a denominator here and move that y to the negative 1 down, make its exponent positive. So final answer is z over y to the first power. We don't have to write the first power. It's implied to be there. So final answer, z over y. All right, that's it for this video.